Welcome back, students. So we are solving the circuits with the nodal analysis. So now we are going to explore the circuits where we have independent voltage sources. So so far we have solved different examples where we have the multiple circuits, but typically like maybe the current sources or a simple one voltage sources. Okay. Now we will look at the examples that contain basically multiple independent voltage sources. So for this example, okay, we basically have a circuit with two voltage sources. One is 12 volt, the other one is minus 6 volt. And we need to solve this examples and to find all voltages, basically V1, V2 and V3. So we are going to use a nodal analysis. So the first thing in the nodal analysis is find the nodes of your circuit. So we can see that basically we have three nodes here. The first one here where 12 volt, this 12 kilo ohm and this 9 kilo ohm is attached. Second is V2, okay, labeled as V2, where 12 kilo and 6 kilo ohm are connected. The third node is V3, where basically 12 kilo, 9 kilo and minus 6 volt are connected. So the rule for the nodal analysis is that we write the equations for each node. Okay, so once we have identified and labeled them, then we will write the equation for each node. Okay, and the fourth node for this circuit was basically reference node, which is ground, and we don't write typically equation for the reference node because we already know that the value of this node is 0, and the purpose of nodal analysis is to get the voltage values. All right, let's come to the V1. Okay, now to write the nodal equation, we need to assume that all currents are leaving. So we can say that the current through V1 is basically this current is leaving, this current is leaving, and then this current is leaving. Okay, so let's write the equation. Okay, for the current that moves goes through the 9 kilo ohm. So I'm writing the equation for V1. So that will be V1 minus second node is basically what? V3 divided by 9 kilo. Okay, now current through 12 kilo, that will be V1 minus V2 divided by 12 kilo. Then comes the current through this 12 volt. Okay, now the current through a voltage source, okay, is this value given? Not given. Okay, the current is always what? Basically difference of nodal voltages divided by the value of the resistance. Okay, this is the typical way of writing a current, okay, as per Ohm law. Or like if you have a dependent current source, then we can write it. So, but here we have an independent voltage source. So now if we try to write it like this, like V1 minus 0, okay, and a typical mistakes that is made is that student consider that voltage source as a resistor and put 12 volt here and put it is equal to 0. So if you are doing like this, like if you are writing the current through this 12 volt source like this one, then this approach is wrong. We cannot write current as a voltage divided by voltage. This is the voltage value. Okay, so basically this whole equation writing will become wrong. Okay, now what is the issue here? Okay, basically we don't need this equation. If you look at this circuit carefully, okay, the purpose of nodal analysis is what? To find the nodal voltages. Okay, if I look at this circuit, okay, let's put focus here. Okay, so V1 is basically connected where? V1 is connected between this node and the ground, right? Sorry, the voltage source is connected between V1 and the ground. So value of V1 is simply we can calculate, okay, what is the difference of nodal voltages here? Like V1 minus 0, that is basically is equal to what? 12 volt. So value of V1 can be found directly because this node is directly connected to the voltage source and the second node is reference. So if you take the difference of nodal voltages here, that will be V1 minus 0 That will be basically just as equal to this voltage value. So simply we can find V1 is equal to 12 volt. We don't need to write a nodal equation for this node here, because we can find the value of this voltage directly. Okay, so this is a very common mistake that is made to solve such kind of circuits. So we have our V1 here. Okay, now let's look at the remaining of the circuit. So if you observe closely here, okay, what is the other thing that you can observe here? So we got V1 is equal to 12 volt. So similarly, same pattern, if you look at now at minus 6 volt. So again, this is connected where? This is connected between node V3 and the ground. So what will be the equation here, students? So for this case, the equation will be, okay, this node V3, okay, minus 0 is equal to minus 6 volt. Okay, so V3 minus 0 is equal to minus 6 volt. So we can say that V3 is basically minus 6 volt. So I can put that here also, that V3 is basically what? Minus 6 volt. So our target was to find all nodal voltages, right? V1, V2 and V3. And we have already found V1 and V2 by just carefully looking at the circuit. We don't have to write nodal equations for these two nodes, V1 and V3. All right. So once we have found that, then we are left with only one node. Okay. So let's have a look at that node now. Okay, that is our V2 node. Now here we can write the nodal equation. So we assume that all currents are leaving. So this current is leaving through 12 kilo ohm, 6 kilo ohm and 12 kilo ohm. So let's write the equation here. So what is the current through 12 kilo ohm? Okay, for the V2 node. V2 minus V1 divided by 12 kilo, that will be the current through the 12 kilo ohm. Then through 6 kilo, V2 minus, what is the second node here? 0, ground, 6K. Then V2 minus V3 divided by again 12 kilo. Okay, why 12 kilo? Like the current through this 12 kilo is equal to 0. So we can simplify, we can put up the values that we know that. So simply one equation, we have a one unknown, y one unknown. Because we know the value of V1 and V3, we just need to find the value of V2. So multiply this whole equation with 12K. Okay, why 12K? Okay, we need to use the lowest multiplier of all the denominators. Okay, so we have 12, 6 and 12, so we can use 12K here. So 12K multiplied with 12K cancelled. So we have V2 minus V1. What is the value of V1? Let's put it here, 12. Again plus 12K divided by 6K. So that will be 2. So 2 times of V2. Again plus 12K, 12K cancelled. V2 minus V3. What is the value of V3? We have minus 6. So we can put minus 6 is equal to 0. Okay. So let's just simplify this one. We have V2, 2V2 and V2. So 1 plus 2, 3, 3 plus 1, 4. So 4 times of V2. Minus 12, this minus minus will become plus. So minus 12 and plus 6. That will give me minus 6 is equal to 0. So what will be V2? 6 over 4. Right, students? Or 6 over 4 is basically what? Simply 1.5 volt. So I have got all the voltages. I have got V1 12 volt, I have got V2 which comes out to be 1.5 volt, and I have got V3 that comes out to be minus 6 volt. So once we know the nodal voltages, we can find anything else, okay, whatever required. If we want to find the current through, for example, 6 kilo ohm, that will be 1.5, okay, V2 minus 0, right? 1.5 minus 0 divided by 6K. If you want to find the current through 9 kilo, that will be V1 minus V3 divided by 9 kilo. So V1 is basically 12, 12 minus plus 6 divided by 9K. If you want to find what is the, for example, the power, okay, dissipated by 6 kilo. So power can be calculated using V square over R. We know what is the voltage drop across 6 kilo, that is V2. So I can put 1.5, square divided by value of R. Okay, so the idea here is like once we apply the nodal analysis, we can get all nodal voltages and we can use them to find any other things in your circuit. Thank you.